Hello everyone and welcome to Computer Vision and Machine Learning tutorials. In this brief computer vision tutorial, we explain how to install the You Only Look Once or YOLO computer vision model. In this tutorial, we will install YOLO version 11. However, everything explained in this tutorial works for older or newer version of YOLO. That is versions after January 2025 when this tutorial is being created. The YOLO algorithm can be used for standard operations in computer vision. Namely, it can be used for object detection, segmentation, classification, pose estimation, as well as for other interesting computer vision tasks. As such, it's very important for robotics applications. Over here, you can see a brief demonstration of the performance of the algorithm. Namely, I took several objects from my apartment, I placed them on the table, and I took my phone and I took this photo. Then, I provided this photo as an input to the YOLO algorithm, and as you can see over here, the YOLO algorithm was able to detect the objects on this photo. Note over here that this image is not being used for training the YOLO algorithm. Namely, I just downloaded from GitHub the model parameters. I didn't train or update the model parameters, and I just performed the inference. And you can see the results over here. You can obtain even better results but by updating the model weights and by using a custom data set. That is by taking several photos and then retraining the model on these new photos. Again, this is a raw image, not some overly processed image, and this shows an amazing performance of the YOLO algorithm. YOLO algorithm is very important for robotics application since you can imagine that the robot has a camera and the robot takes an image and then the robot can pick or place these objects or perform some complex manipulation. But before we explain how to install YOLO, let's first explain the prerequisites. First of all, you need Python version 3.9 up to version 3.12. This is mainly necessary for installing the PyTorch CUDA version locally. Namely, PyTorch CUDA version requires Python 3.9 up to 3.12. If you're watching this video after January 2025, then it might be possible to install PyTorch CUDA version on Python 3.13 or later. Check the PyTorch CUDA website for prerequisites, and I'm going to explain how to do that later on. Then, you can run YOLO on a computer that only has a CPU. However, we suggest to run it on a computer with GPU. You should have an NVIDIA GPU which also supports CUDA if you want to exploit the power of GPU computing. I didn't test YOLO on AMD GPUs or on some other GPUs. Then, you should install Microsoft Visual Studio C++ with C++ compilers. This is necessary for installing and running the PyTorch CUDA locally, and I'm going to explain how to do that. Then, you have to make sure that you have Git installed on your system as well as Git support for large-scale files. Don't worry, I will explain how to do that in the video tutorial. Let's explain how to install the prerequisites. First of all, go to the python.org downloads webpage. Then, don't click on download Python 3.13 since PyTorch CUDA cannot be executed on Python 3.13. If you scroll down, you will see the previous versions of Python over here. For example, you can use Python 3.12.8. You click on download link and you proceed further to download the distribution. Then you need Visual Studio C++ compilers. To do that, you need to go to this official visualstudio.microsoft.com VS Features C++ website. Then over here, you need to select the proper version. The community version 2022 is completely free and it comes with C++ compilers. After you click here, a file will be downloaded and double click on that file and the compilers will be installed. Then, Later on, we are going to install PyTorch by using the command generated from this website. I'm going to explain this later on. Then you need Git in order to download YOLO from Git. You simply can go to this website, then you can click on Git version for Windows, double click, and Git will be installed. And in addition, you need Git large file storage support. For that purpose, go to this web page and click on the download link to download Git large file storage support. After you do that, we can proceed further. Okay, let's start with installation process. First of all, click over here and search for command prompt. Start the command prompt and let's start typing the commands. First of all, make sure that you have Python installed on your system. To do that, you can simply type Python with double dash version and you should see the Python version. Let's then go to the C drive and let's create the workspace folder. I'm going to call it as test YOLO. Then I'm going to navigate to the test YOLO folder, and inside of this folder I'm going to create a Python virtual environment by executing this command. So why I'm doing this? Well, a standard practice is to always create a Python virtual environment when you want to install new packages or when you want to write code. The next step is to activate this Python virtual environment. To activate this Python virtual environment, we need to execute a script file that's located in this folder and in additional subfolder. So we need to type this command. Let me now copy it so you can see it. This command over here to activate the virtual environment. Good. Now we are in the Python virtual environment and we can install all the libraries and packages. First of all, we need to install setup tools. Consequently, type pip install setup tools. Then, after we install setup tools, we need to install PyTorch. To install PyTorch, go to this website. Then, complete this selection table. We want stable version. We are on the Windows system. We are using pip to install commands. We are using Python. And let's select this CUDA version over here, 12.4. Copy this command. Go to the command prompt, paste this command, and here it is. Good. Now over here, be patient, since it's going to take a while to install PyTorch. Now in my case, as you can see over here, I'm using a cached version. Namely, since I often install or uninstall packages, Python already downloaded on my computer everything, and then Python is installing from my computer. However, in your case, you will see that the packages are downloaded from the internet. So be patient. It might even take 2 or 3 minutes to install PyTorch. And finally, we need to install YOLO. To install YOLO, we need to run this command. Pip install git plus, then here's the link, and we want the main branch. That's it. Simple as that. Press enter and be patient. It's going to take a while to install YOLO. Okay, so let's see. Again, I'm using a cached version since I'm often installing and uninstalling. However, in your case, you will download everything from the internet. Okay, so let's be patient. The next step is to create a test photo. The easiest way to create a test photo is to take your phone, put several random objects on a table and take the photo. Then copy the photo to your computer. Or you can use my photo. Here's my test photo. I will provide a link to this photo in the description below this video. Now, what I will do now, I will copy this photo to my folder. That is to my workspace folder I just created. So the workspace folder is here, and here it is. Good. The next step is to create a Python code that will test YOLO. To do that, go to the command prompt and use your favorite Python editor to create a Python file. I'm going to use Visual Studio Code, so I will type code dot. If you don't have Visual Studio Code on your system, don't worry, I created a separate video tutorial on how to install Visual Studio Code. You can find that video tutorial on my YouTube page. Here it is. Then over here, I will create a new file. To create a new file, I'm going to click on File, New File, and I will call the file as test YOLO, and don't forget the extension Py. And save this file in the workspace folder. Here it is. And here, to save time, I'm going to simply paste the content of this test file. Here it is. Let's explain this file line by line. First of all, we need to import YOLO. Then we need to select a model. Over here, we have several options for the model. To load the model, you just need to type the model name over here. You have YOLO 11N, YOLO 11S, YOLO 11M, etc. Now, this model is the smallest one. This is a little bit larger, then larger, then larger, and the largest one. The largest one should have the best performance. Here, for illustration, I'm going to select this model over here. Then over here, I'm providing a test image to my model by specifying the image name. And here it's very important that the image is located in the same workspace folder as this code. Then the inference will happen over here by calling the model function. And note over here that we are not providing any additional parameter to YOLO. Now, we are using the default settings of this function, and the default setting is to perform object detection. If we want to perform some other operation, such as model segmentation, or if we want to pose estimation or something else, we need to provide additional parameters. Okay, then the results will be stored in this list called results. Then we are iterating through this list results, and we are doing the following. We are creating boxes around the objects, we are creating masks, we are creating key points, we are creating probes, OBBs, and finally we are saving the processed image to the disk. So what will happen behind the scene? YOLO will do its magic, then it's going to draw boxes, confidence interval, denote the objects, and save the results as results.jpg image. Okay, so let's run this code. To run this code from Visual Studio Code, you first need to tell to Visual Studio Code to use the Python interpreter inside of the virtual environment. To do that, press and hold Ctrl, Shift, and P, then search for Python, select interpreter, then make sure that you select the interpreter inside of our virtual environment. Here it is, and simply click on Run, and magic will happen. Now over here you can analyze the response. Now first we are downloading the model from internet, and you can see, bang, literally in 46 milliseconds we were able to detect the objects. So where are the results? Well, to retrieve the results, go back to the workspace folder, and over here you're going to see the file called results.jpg. Here it is. Okay, you can see book, cup, scissors, and toothbrush, which are properly detected. Another thing to observe over here is the model file that's being downloaded from the internet. So next time you try to run the model, the file will not be downloaded. The file already exists on the local computer, and here it is. So let's now change the model. For example, let's use a smaller model, and you will see that the performance is not as good. So if I change over here, a new model will be downloaded, a smaller model, and let's see the results. So if we go here, if I go here, and if I click here on the results, you'll see that I have false positives over here. You can see that this object is not properly detected, this object is not properly detected, etc. Another thing to observe is that over here you have a smaller model. You can see that this model is only around, I think, let's see, 5 megabytes. This is the smaller model. The bigger model is 50 megabytes, which is really, really small, still very small. Okay, that's all for today, and thanks for watching.